In this video, I am going to discuss about functions, which is from class 12 maths chapter 1, and this is going to be the first lecture on functions. And in this video, I'll discuss about these points, basic idea about function, domain, range and codomain of function, then types of functions, and we will solve few questions basic level for getting the concept. So these are the points I am going to discuss in this video. Now, before I start about explaining about the definition of a function, I am taking an example at first, which will make the concept clear. A function f from set A to B defined by fx equal to 2x plus 3. And the function is from set A to B, and set A I am taking with elements, it's a simple set with elements only 1, 2 and 3. Then we'll find the corresponding values of fx in the second set. The first set A denoted by x, the elements are denoted by x. The elements of second set are denoted by fx or y. The first set also called pre-image. Elements are called pre-images, and the second elements in second set are also called the images. Now let us see the elements of this 1, 2, 3 under this function. If we take x is 1, then 2 1s are 2 plus 3, that is 5. That means 1 is corresponding with 5. If we take the value of x is 2, 2 2s are 4 plus 3 7, so the element 2 is corresponding with 7. And if we take x is 3, 3 2s are 6 plus 3 9, so 3 is corresponding with 9. So we can say a function is a correspondence. A function f a to b is a correspondence which associates elements, each element of set A with unique element in set B. Now, each element of set A, the meaning is in set A, each and every element must have image in B. There should be no element in set A without having images in B. That is the first condition. Second condition, unique element. Unique means only one. That means only one. That means element of set A must have only one image in B. No element can have more than one images, according to the definition of function. So this is about basic idea about a function. What we understood is a function is a correspondence from one set to another set which associates each element of set A with unique element in set B. Elements of set A are denoted by x, which are also called pre-images under the function, and elements in set B are denoted by fx or y, and which are called the images under the function. Now, the whole set A is the domain of the function. The set A is the domain of the function. That is the first set under the function. And then, according to the definition of function, in set B, there may be elements, say elements 10, 11, 10, 11 I'll take. According to the definition of function, there may be elements in set B without pre-images in set A. It is possible. And then, those elements in set B having pre-images in A makes the range of the function. So in this case, the set of elements which are having pre-images in set A are 5, 7 and 9. The set with 5, 7 and 9. And this makes the range of the function. And then the whole second set is codomain of the function. And then if there is no element in set B, if there is no element in set B without pre-image in set A, then the range and codomain will be the same. And if there is extra element in set B without having pre-images, then range and domain different. Range and codomain will be different. Codomain is the whole second set, and the range is the set of those elements in B which are having pre-images in set A. So this is the basic idea about function, its domain, range and codomain. The next is different types of functions. Types of function, the first type is 1-1 function, which is also called injective function, and I am taking a diagram to explain 1-1 function and example also. 1-1 function is like this: A element P, B element Q, C element, image. A image is P, B image is Q, C image is R. That means different elements in set A having different images in set B. And this is the 1-1, this is type of 1-1 function. different elements in A have different images in B, and theoretically to prove a function, to check a function is 1 1 or not, the process is like this. Consider fx1 if equal to fx2, and taking an example with to explain. If we take fx1 from this function, fx1 will be in place of x writing x1, so it will be 2x1 plus 3. X is replaced by x1, and fx2 means x is replaced by x2, so it will be 2x2 plus 3. And then simplify, and if we can show x1 is equal to x2, then we will say function is 1 1, that is injective. So theoretically, if we take fx1 equal to fx2 and we can show that x1 is equal to x2, the meaning is different elements in A have different images in B. That if elements are equal, images are equal. So if we say reverse the statement, elements are equal, then images are equal, and if we reverse the statement, it means that if elements are not equal, then images are also not equal, which means that different elements in A will have different images in B. And this is the theoretical proof, theoretical way, system to check a function is 1 1 or not. Type 2 is a many one function. Many one function is like this. Different elements in A will have same image in B. Here I am taking A is having image P, another element B also having image P. So many one function is different elements in set A will have different images in B, and the theoretical process of checking a function is many one or not, the same as in 1 1. The process is same as we have taken for checking 1 1 function. Same, consider fx1 equal to fx2, and then same way the function is here, fx1 is this and fx2 is this, replacing x by x2 here, replacing x by x1 here. And then if we can prove that x1 is not equal to x2, x1 is not equal to x2 for some values of x1 and x2, at least for one pair of values of x1 and x2, if we can show that images are equal, but the elements are not equal, we can understand from here. So this A is x1 and this B is x2. So in this case, two different elements, image is same. x1 not equal to x2, x1 is A, x2 is B, two different values, but their image is same. So this theoretical diagram, this is called arrow diagram, arrow diagram, theoretically it says like this: two different elements, x1 not equal to x2, two different elements having the same image, and this kind of function is not 1 1. Not 1 1 is called many one function. A function which is not 1 1 is called a many one function. So we have to keep in mind different elements having same image, at least two different elements having the same image. There may be more elements having the same image. Type 3 is onto function. Onto function also called surjective function. Onto function, the condition is every element in B must have pre-image in A. So onto function can be two types again. It can be 1 1 onto. This diagram I have taken is representing a 1 1 onto function. 1 1 function because different elements in A have different images in B, and onto function because in set B there is no extra element. That means every element of B has pre-image in A, which makes the function onto. So this is a 1 1 and onto function. And another example we can have many one and onto function. Many one, we can see here different elements having same image, which makes the function is many one. And in set B there is no element without pre-image in A, which makes the function is onto. So this second diagram, it is representing a many one and onto function. So this is the diagrammatically we understand the function. It can be 1 1 onto, it can be many one onto, but theoretically how to prove? Theoretical process is like this. I am taking the example, and fx, it will be given in the question, fx, and fx is represented by also y and 2x plus 3. We will write it x in terms of y, so it will be y minus 3 by 2. And if we can show this belongs to set A for all y belongs to set B, if we can show this expression always belonging to set A for any value of y belongs to B, then we will say function is onto. That is also called a surjective function. Now, what is the meaning? This expression is always belonging to set A for every element of every value of y belongs to B. The meaning is for every element in B, the preimage belongs to A. This belongs to means preimage belongs to set A. So this is about a onto function. And then the fourth type is into function. Into function is almost similar concept, but there will be at least one element in set B. I can write S here, at least one element in set B which is not having pre-image. So if we say this diagram, it is representing a 1-1 function because different element having different image in B, and the function is also into because this element S is not having pre-image in A. So this diagram representing a 1-1 and into function, not onto. A function which is not onto is called into. Since this element is not having pre-image, so it is not onto. Second diagram, also I'll take one element, say R. R is not having any pre-image. So this diagram representing a many-one function because two different elements having the same image, which makes the function many-one. And then this element R is not having pre-image, makes the function is into. Theoretically, writing almost similar, but in this case there will be not belonging. This expression x writing in terms of y, it will not be belonging to A for at least one value. We can write here for some value of y belongs to B. At least for one value of y, it will be not belonging to B. At least for one value, meaning here it is for S, the preimage does not belongs to set A. For R, preimage does not belongs to set A. For at least one value of y belongs to B, this expression x writing in terms of y, it will be not belonging to A. The meaning is there is some element in B for which the preimage does not belongs to A, as it is here S has no preimage in A, and then the function f is not a onto function, and not onto function is called a into function. So these are the idea, these are the concepts on different types of functions. That is, function is 1-1, many-one, and a function can be onto, into. On onto we have seen can be many-one onto, 1-1 onto, and into also it can be many-one into, 1-1 into, many-one into. So these are the idea about the types of functions. Next we will solve some questions. Okay, before starting solving questions, we have to keep in mind that a function which is 1-1 is also called a injective function. A function onto is also called a surjective function, and a function which is both 1-1 and onto is called a bijective function. So this points we have to keep in mind, because in the questions it can be asked in different ways. Show that 1-1, it can be asked show that injective, or check for injective in that way. So we have to keep in mind this. The first question I am taking here, a function from set of natural numbers to set of natural numbers defined by fx is equal to 2x plus 3. Whenever starting to solve a question, you always mark first set is A, second set is B, and we have to write it in order when we solve theoretically. So this question I will show first theoretically, and then I will explain with this diagram. Theoretical process of checking for 1-1 is consider fx1 is equal to fx2, and this is the function. From this function, if we write f of x1, that means I have to write in place of x x1, so it is 2x1 plus 1 equal to x2, in place of x x2, that is 2x2 plus 1. So 1 is getting cancelled, 2x1 is equal to 2x2, so very clearly 2 also is getting cancelled, and we are getting x1 equal to x2, and this is the theoretical condition which says that the function is 1-1. So we can write f is 1-1. Then onto theoretical process is, first we will take the function given fx, this is the function given we are taking, and we know fx is also represented by y, denoted by y. So y equal to 2x plus 3, 1. And then we'll write it in terms of x equal to, x is equal to in terms of y minus 1 by 2. Now for any value of y in natural number, will it be belonging to set A? Here it is f is from n to n, that means a, b. So for any value of y in b, will this expression give a number which is in set A? Let us see. If we take y is say 4, if we take y is 4, then what will happen? 4 minus 1 is 3 by 2. 3 by 2, it will be not belonging to natural number. It will be not belonging to natural number. 4 y is equal to 4, and many other number I can show, even for 6 also, etc. For many numbers we will see this expression will give a number which is not a natural number, and we can understand this from the diagram also. And since not belongs to, so we can write the function is not onto, that is a into function. We can understand this through diagram also. This is the function given, and if we take x, the first set is x, elements represented by x, second set elements are the values of fx. So this is the function. If we take x is 1, 2 into 1 plus, so 1 will be corresponding with 3, 2 will be corresponding to 3 is 6 plus 1, 2 is corresponding to 7, corresponding to 7, no, 2 is corresponding to 2 is 4 plus 1, 5, 2 is corresponding to 5, 3 is corresponding to 7. So we can clearly see in the diagram that this number, natural number 1 is not having pre-image, 2 also is not having pre-image, only this 3 is having pre-image under the function, 5 is having pre-image, but the remaining numbers 1, 2, 4, 6, these are the numbers which are not having pre-image. And even if we can show a single number in the second set and not having pre-image in the first set, then the function is not onto, that means a into function. The next question, taking a function f from real number to real number, we will mark it a and we will mark it b, defined by this, and we have to check the function is 1 1 or not, onto or not. 1 1, keep in mind, is also called injective, and onto also called surjective. So we'll do it theoretically. Theoretical process to check for 1 1 is consider fx1 equal to fx2, and this is the function. If we take f of x1, it is 2x1 minus 3, and f of x2, that means x replaced by x2, 2x2 minus 3, this is getting cancelled. You are getting 2x1 is equal to 2x2, 2 is also getting cancelled. Finally x1 equal to x2, which is the theoretical condition, and it says that the function is, it concludes that the function is 1 1. Therefore f is 1 1, that is the injective function. Surjective function, given the function fx equal to 2x minus 3, we will start with the given function. Fx is also denoted by y, and you will write it x in terms of y, x in terms of y, so it is y plus 3 divided by 2. Now will it be belonging to first set, belonging to a for all y belonging to b, second set? Here first set is real number, second set is also real number. Now will it be belonging to real number for y belongs to b? Yes, any real number plus 3 is a real number, because we know the sum of any two real number is again a real number, and any real number divided by 2 is also real number, and hence it will be always belonging to R, and therefore f is onto, that is a surjective function. And since the function is both 1 1 and onto, so you can say it is a bijective function. The next question I am taking, a function from z to z, integers to integers, we will mark it a, mark it b. In this case both the sets are same, but in some cases sets may be different. Then we have to very carefully, we have to write a and b the places to keep the order correct. The function given fx equal to x square, and we are going to check it for 1 1 and onto. 1 1 theoretical process is, consider fx1 is equal to fx2. Now fx1 from here, it will be x1 square is equal to x2, fx2 is x2 square, and whenever we remove square there will be plus minus. That means x1 will not be equal to x2 for negative values. For positive values they will be equal, for negative values they will not be equal. And this one I will explain with this diagram also to make it clear. And whenever we get not equal, we will say f is not 1 1, that is a many one function. Theoretically we have proved x1 not equal. Whenever square is there, plus minus will come, and whenever there is both plus minus, remember it will not be always equal for negative values. We can understand through this example. First set it is x, and second set is fx, values of fx is x square here. Now 0 square is 0. Under this function I am finding the image as 0 square is 0, 1 square is 1, minus 1 square is again 1, minus 1 square is again 1. So we can very clearly see here 1 and minus 1, two different numbers having the same image. So here x1 not equal to x2, like x1 we can say x1 is 1 and x2 is minus 1. So x2, two different numbers having the same image. The numbers are different but their images are same. So we can clearly understand from this diagram, two different elements having same image, the function is not 1 1. So we can say f is not 1 1, that is a many one function. And we are going to check for onto also. Onto will take the function fx is given x square, fx is denoted by y is x square, and we will write it x in terms of y, so it will be plus minus root over y. Now it will not be belonging to z. For we can take numbers like for z is equal to 2. If we take 2, then root over 2, square root of 2 is not a integer, it cannot be an integer. Square root, even for 3 also, not 4, for 4 it will be belonging. We will always try to show for which number it is not belonging. Even if we can show for one number also, then we will say it is not. Therefore f is not onto function, that is a into function. The next question I have taken a function z to z, or I can write from real number to real number. Fx is equal to modulus of x, and I'll check for 1 1 1 2. This one 1 1 we can explain with an example. If we take say f of 1 is modulus of 1 is equal to 1. This is the function we are taking. If we take f of minus 1 is modulus of minus 1, modulus of a number is positive. So clearly what we have got here, clearly f of 1 is equal to f of minus 1, but 1 not equal to minus 1. So this is matching with the theoretical condition. F of x1 is equal to fx2 implies x1 not equal to x2. That means two different numbers having the same image. We can understand through this diagram. Modulus of 0 is 0, modulus of 1 is 1, modulus of minus 1 is also 1. So these two values x1 we can take and x2, these two different numbers having the same image 1 under the function. So when two different numbers having the same image, the function is not 1 1. Therefore f is not 1 1, that is representing a many one function. It is representing a many one function. Then about onto function also we can explain with the diagram. Modulus of any number is modulus of any real number is always positive. So in this case, these negative real numbers not going to have any pre-image. Negative of real numbers, not any negative real number not going to have any pre-image under the modulus functions, because modulus of any number is always going to be positive. So we can explain with diagram, with the diagram, or this way of drawing diagram for real number is actually not correct. Real number is drawing on real line. But for understanding the rough, for rough work we can draw it, it is not a problem. For understanding you can draw the diagram. And for not onto, it will be not onto, we can write the explanation that the negative real numbers not going to have any pre-image under the modulus function. Minus 2, minus 3, minus 4 will not have any pre-image under the function fx is equal to modulus of x. And therefore the function is not onto, that is a into functions. So this is the end of the first lecture, and in the next lecture, lecture 2, I'll give the complete solution of exercise 1.2 from textbook.